Welcome to this video. We will implement an open source model combining vision and LLM to count the balls on this rotating Christmas tree. First, we will test the model on a standalone image. After importing the necessary Python packages, we copy some utility functions from InternVL, notably a function to find from image the best height to width ratio for the model. Here is the most important utility function of InternVL. It allows you to split the image into tiles of 448 pixels, depending on the height-width ratio of the image, while adding at the end of the list of tiles a tile representing the entire input image. This technique allows better use of the image resolution, without having to modify the base of the vision encoder, which has a fixed input size. Finally, the load image function groups all the processing, conversion of the image into a tensor and normalization, split tiles, and adding the last global tile. We create a function to download the InternVL model from Hugging Face by specifying quantization options essential for the model to fit in memory of a consumer-grade graphics card, by enabling the option to offload GPU memory to central memory when possible. Don't forget the flash attention option, which saves a lot of memory. Finally, we add a function to organize the inference of InternVL. We load the model. By calling the NVIDIA utility, you can see that the video memory consumption is reasonable. We visualize the first image of the Christmas tree video to evaluate the model's performance on a fixed image. We launch the inference on the image. By asking for the list of decorations on the tree, we get a correct list of decorations. From an initial description of the image, the model can provide the coordinates of bounding boxes, corresponding to a particular object in a specific context. For example, giving the position of the yellow star at the top of the Christmas tree. Even if the bounding box is not precise, detecting an unusual object in a specific context is very interesting. If you want to create a lot of self-labeled data to train a classic real-time object detection model and transfer precision from the InternVL model, you can do so without manually annotating thousands of images. Now we are testing the model on a video. We are adding a specific functions to handle a sequence of images, notably a function to extract subsamples from the video, and we limit the sequence to 6 images over the entire clip. To handle image sequences, we use only one tile per image, so you can understand the interest of this tile management to take advantage of either the image resolution or an image sequence. Here we see how the sequence inference is organized, by indicating in the prompt the successive images of the video. We also create an image mosaic to debug the sequence of images provided at input. The model provided the correct balls count and its colors. Of course, this type of task could be difficult for a vision model, and some examples may not work so well. But this model can be adapted and improved with LoRa specifically for this task and this type of data. The fact that the base model is already able to respond quite correctly. This suggests that the number of examples needed for its adaptation would be reasonable. See you soon in the next video.